Welcome. We want to take a look at solving another exponential equation. This one is different than the previous because we have different bases. Previously, we had base to a power is equal to a number, and that's it. Here we have base to a power is equal to some other base to a power. But really what we have is we have just base to a power is equal to a number because x is just a placeholder for a number, and 4 to a power is just a number. So we can think of it as an exponential equation that has base 3. So if I were to rewrite this in logarithmic form, I'm looking to write it as logarithm base 3 of 4 to the x is equal to x plus 2. Right? We're going to, if we rewrite base to a power is equal to a number, we rewrite it as logarithm base of that number is equal to the power. So our base is 3. Our power is x plus 2, and our number is 4 to the x. Now, why is this good? Well, because I have the power rule, right? I can bring that power out. So I have x times the logarithm base 3 of 4 to the x is equal to, sorry, of just 4 now, is equal to x plus 2. Again, I'm bringing that power down in front as a coefficient. I can get all of my x terms on one side. So I'm going to subtract x. So I have x times the logarithm base 3 of 4. Then I'm subtracting x is equal to 2. Pull out the common factor of x. I'm left with logarithm base 3 of 4 minus 1 is equal to 2. Again, that x times that. I can divide by this number to isolate the x. And I'm done. Again, this is a number, logarithm base 3 of 4, and then we are subtracting 1. The 1 is outside of the logarithm. All right. So we chose 3 as our base, 4 to the x was our number on the other side. We could have alternatively chosen 4 as our base and 3 to the x plus 2 as the number on the other side. So 3 to the x plus 2 is equal to 4 to the x. If I were to choose 4 as my base, I would write this as logarithm base 4 of 3 to the x plus 2 is equal to the power on 4. Again, when we rewrite logarithm base number, logarithm of the number, and it's equal to the power. Now I can pull x plus 2 down as my coefficient. So I still have logarithm base 4 of 3. Distribute into the parentheses, x times the logarithm base 4 of 3 plus 2 times the logarithm base 4 of 3 is equal to x. I'm going to, let's see here, I can subtract this from both sides to get 2 times the logarithm base 4 of 3 is equal to x minus x times the logarithm base 4 of 3. Pull off the common factor of x to get 2 times the logarithm base 4 of 3 is equal to x times 1 minus the logarithm base 4 of 3. And let's see here. Now I would want to write, divide by that. So I'm going to get x is equal to 2 times the logarithm base 4 of 3 divided by 1 minus logarithm base 4 of 3. Now you might say, hey, we found 2 answers. Both of them are correct. Dr. Reynhout is saying, yes, indeed I am. But they don't look the same at all. You're right, they don't. How could we verify that these two are the same things? Well, we could use the change of base formula. We could rewrite logarithm base 3 of 4 as logarithm base 3 of 4 divided by logarithm base 3 of 3. If we were to do that and then simplify, that would give us what we're looking for here. Again, that would be logarithm let's see here. If I wanted to change it to base 4, logarithm base 4, I think maybe I said that backwards. Logarithm base 4 of 4 divided by logarithm base 4 of 3. That sounds better. Yep. So I apologize. I think I said that wrong at first. Anyway, change of base formula. Also, a word of warning, as you approach other textbooks, they will teach you different ways to solve these things. If you use different ways, that's okay as long as they're correct. Right? I mean, the method that other texts present is correct. I would encourage you to use the method here if you want consistent approach every time. If you would like to take a different approach, as long as you're using logarithms appropriately and using logarithms, then you should be fine. If you have any questions or concerns, of course, reach out.